let's look at a little bit different type of example, and that's how to calculate KSP from equilibrium concentrations. So this time we're calculating the value for KSP from equilibrium concentrations. Okay, so let's look at an example. So fluorite, which has that formula, is slightly soluble. Let's go ahead and write out the equation. So it dissolves according to the equation. Now you should be able to do this even if I don't do it for you. So you should be able to look at calcium fluoride or fluorite and write out the expression. So that would be CaF2. And then we're going to put it the equilibrium arrows there. We're going to have calcium 2 plus and 2F minus. So you should be able to do that. These are all aqueous. Sometimes I neglect to write that down since they are. Now, the concentration of calcium 2 plus in a saturated solution of fluorite is 2.15 times 10 to the negative 4 molar. So the concentration of calcium 2 plus in a saturated solution of fluorite is 2.15 times 10 to the negative 4 molar. So we want to know what is the value for the solubility product constant. Okay, now I want to point out something here also is that a lot of times you're just going to have this written out instead of them writing out KSP explicitly. So you have to know that that's what that means. Okay, so we're looking for the value for that. So let me rewrite our equation here so we have it so we can refer to it. So calcium 2 plus aqueous plus fluoride anions. Okay, so there's our expression, and what we want to do, we also know that calcium 2 plus, let me write this too, concentration is 2.15 times 10 to the negative 4 molar. Okay, so we have everything that we need to solve this problem. Now we want to calculate KSP, the actual specific value. And so when we write out our expression here, it's going to look like this. And first we have to figure out how much of the fluoride anion is present. Now we didn't get that information in the problem. So we have to figure that out for ourselves. So what we're going to do is use stoichiometry. So we notice that for every 1 mole of calcium 2 plus, for every 1 molar that's dissolved, we're going to get 2 molar of the fluoride anion. So it stands to reason that the fluoride anion is simply 2 times 2.15 times 10 to the negative 4 molar. And it is. And so if we do that math, it's going to be 4.3 times 10 to the negative 4. Okay, so now we know our fluoride anion concentration. So now all we want to do is substitute it into our equation. Don't forget to square the fluoride anion, or else you'll get the wrong answer. Okay, that's going to be squared. And let's go ahead and do the math, run that through the calculator. It's always a good idea to practice getting it in your calculator properly so you get the right answer when it comes time for the test. And there's the value for KSP from that. So this system is at equilibrium, and we were given the equilibrium concentration of the calcium 2+, so we can use that information to calculate the KSP for the reaction.